This demo shows my prototype of Kafka node pools. The Kafka node pools allow you to deploy a Strimzi-based Kafka cluster, which has different sets of Kafka brokers, which are each using different configurations. The prototype is using a feature gate, so first we need to make sure that the feature gate is enabled in the cluster operator deployment. So I can check that the environment variable Strimzi feature gate enables the Kafka node pools feature gate. With that said, we can check the custom resource for deploying the Kafka cluster. At the start, it looks like a regular Strimzi Kafka resource. It even has the replica and storage fields, but in this case, they will be actually ignored because the feature gate is enabled. In the Kafka resource, we configure the things which are shared for all brokers, such as the listeners, the configurations, or in this case, also the ZooKeeper cluster, which is shared by all the Kafka brokers. But then we add additional resources. These resources are named Kafka node pool, and they contain the configuration of the different sets of brokers. So for example, this node pool has two replicas, which means it will have two different brokers. It configures the resources for the brokers and some JVM options, and it also configures the storage. In this case, it has two volumes, each 100 gigabytes big. And then I have a second pool, which has a different name, and it has also two replicas. It actually has the same amount of resources, but this time, instead of using two volumes with 100 gigabytes each, I'm using a single volume with 200 gigabytes size. So when I apply this resource, I can switch to the next window where I can first see the ZooKeeper cluster being deployed. That doesn't really change, and the node pools do not really impact ZooKeeper at all. And after the ZooKeeper cluster is deployed, I will be able to see the different Kafka node pools deploy as well. Now the ZooKeeper cluster is deployed, and we can see the broker pods spinning up as well. You can see that each of the pods has still the broker ID in its name, and it has also the name of the pool from which it was created in the name. And as before, once all the brokers get up and running and get ready, the operator will proceed and deploy the entity operator for managing users and topics as well. Now, when the cluster is deployed, we can, for example, check that the storage was properly created according to the specification in the node pools. So when I list the persistent volume claims, I can see that I have the two sets of the JBot storage with 100 gigabytes for the Aston pool, and the second pool has only one disk for each broker with the size of 200 gigabytes. I can also independently scale the different pools. The Kafka node pool resource supports the Kubernetes scale sub-resource, which should serve as a basis for building a proper auto-scaling solutions in the future. Thanks to that, I can, for example, do kubectl scale Kafka node pool Aston to 3 replicas. And I can see that the operator immediately sees that and spins the new pod. Now, because the broker IDs 2 and 3 were already taken, it gets automatically assigned the next available broker ID, which in this case is 4. So that's the demo of using the node pools. In the next video, we will have a look at how the node pools help when running the ZooKeeper-less Kafka clusters.